What if everything you thought you knew about time was a carefully constructed illusion? We experience it as a constant, a simple, unwavering tick-tock of a clock, moving always forward. But for the minds that grasp the universe, the physicist's time is a funhouse mirror, bending, stretching, slowing down, and even disappearing, depending on where you are and how fast you are moving. The universe doesn't operate on one universal clock. It functions on countless individual clocks, and they all run at wildly different speeds. We will delve into the secrets of the cosmos to explain why your personal future could already be someone else's distant past, and what the smallest, most fundamental unit of existence truly is. Today, we're dissecting the very fabric of reality itself. We are explaining 12 mind-bending concepts that fundamentally define the existence of time in our universe. Prepare to have your most basic assumptions about existence challenged. Let's begin exploring the 12 rules of time. The space-time fabric, the foundation time, is not an independent entity, separate from the space we occupy. It is intrinsically interwoven with space, forming a unified four-dimensional structure known as space-time. This concept, originated by Albert Einstein, provides a breathtaking new perspective on gravity. Massive objects, such as stars and galaxies, do not pull things towards them in the traditional sense. Instead, they warp the fabric of space-time itself. And objects simply follow the natural curves and indentations created by that mass. Gravity, then, is merely the effect of moving along bent space-time. This single rule is the foundation for all modern cosmology. 2. Time dilation, the relativity of speed. This is the most famous and perhaps the most mind-bending reality of time. Time dilation states that time slows down for an object the faster it moves through space, or the closer it gets to a source of extreme gravity. If you were somehow capable of orbiting a black hole for just 1 hour, an entire year could pass here on Earth. This effect isn't theoretical. It's a measurable reality. Even the subtle difference in gravity between the first floor and the top floor of a skyscraper causes a tiny discrepancy in the passage of time. A discrepancy that GPS satellites must constantly correct for it to function. 3. The arrow of time, the law of disorder. Why can we only move forward into the future and never back to the past? This one-way street is known as the arrow of time, and its direction is governed by a simple concept: entropy. Entropy is the universe's measure of disorder. The universe always moves from a state of low entropy, a pristine, ordered state, to a state of high entropy, which is chaos and disorder. You can smash a glass, but you cannot unsmash it. This unstoppable, irreversible increase in universal disorder is the fundamental, simple reason your clock ticks forward and never backward. 4. The block universe theory, the static reality. Imagine the entire lifespan of the cosmos from the Big Bang to its theoretical end existing all at once, like a giant, unchanging four-dimensional sculpture. That is the block universe theory. It suggests that the past, present, and future all exist simultaneously and permanently within this fixed block of space-time. Our human experience of time passing is merely an illusion, a kind of sequential spotlight. Our consciousness shines on this unchanging reality. If this terrifying concept is true, then your future actions are already unchangeably etched into the fabric of reality, raising profound questions about the very nature of free will. 5. The Planck time, the smallest second. Can time be infinitely divisible, or is there a smallest unit? Physicists believe there is an absolute, non-negotiable minimum unit of time, known as the Planck time. It is the incredibly minute duration of roughly 10 to 43 seconds. Anything that happens faster than this, or any measurement smaller than this, is considered physically meaningless. Below this threshold, the classical laws of physics break down entirely, and space-time is no longer continuous, but is theorized to exist as a foamy, quantized concept. It is the absolute zero of temporal measurement. 6. Tachyons and retrocausality, the time travelers. While purely hypothetical, tachyons are a class of particles theorized to exist only while traveling faster than the speed of light c. According to the mathematics of relativity, if any particle were to exceed the universal speed limit, its calculations would suggest that it travels backward in time. This is the concept of retrocausality, meaning an effect could theoretically occur before its cause. Tachyons have never been observed, and this absence is often cited as a natural check that reinforces the immutable reality that the speed of light is the absolute barrier for all mass-bearing objects. 7. The cosmological constant, the speed regulator. The universe is expanding, and it's not slowing down, speeding up. This phenomenon is driven by an enigmatic energy density of empty space, known as the cosmological constant. This energy is inexorably linking the ultimate fate of the cosmos to the very nature of time. As space stretches at an ever-increasing rate, the available time for light and information to travel increases dramatically, fundamentally altering the observable universe over vast epochs and diluting the underlying structure of spacetime itself. 8. Quantum time, the microscopic mystery. When we look at the subatomic level, the smooth, predictable flow of time seems to vanish. Quantum mechanics, the science of the very small, often treats time very differently, sometimes omitting it entirely from its fundamental equations. Some of the deepest theoretical models suggest that at the most granular level, time might not flow in a river-like manner at all. Instead, it may simply exist as a static, unchanging parameter that only emerges and becomes noticeable when measured on the classical macroscopic scale of our everyday lives. 9. The chronology protection conjecture, the time police. If time travel were possible, wouldn't we be overrun by tourists from the future? To address this fundamental paradox, famed physicist Stephen Hawking proposed the chronology protection conjecture. This idea implies that the very laws of physics must prevent the formation of any kind of time machine, specifically structures known as closed time-like curves. Any theoretical attempt to travel backward in time would be violently stopped by an uncontrollable buildup of energy or unpredictable quantum chaos, ensuring the timeline remains safe from self-contradictory paradoxes. 10. Gravitational lensing, seeing two pasts. Extreme concentrations of gravity, such as those found near giant galaxy clusters, do more than just bend light. They bend the path of time itself. This is known as gravitational lensing. The bending creates a distortion in space-time, can cause us to see the same distant object at two different times in its history. The light from a single far-off galaxy can travel around opposite sides of a foreground mass, taking two very different paths that arrive at Earth thousands of years apart, meaning we literally see the object as past self and its future self side by side. 11. The observer affects consciousness and time in the strange world of quantum physics. The very act of observing a system fundamentally influences its outcome, some more radical, but increasingly discussed. Interpretations of quantum time suggest that the flow of time itself is linked to the consciousness and perception of the observer. Without an intelligence to measure and record the sequential passage of events, these theories propose that time might have no objective, independent reality. This places human consciousness directly at the absolute heart of the universe's ongoing clock. 12. The end of time, the final rule, the ultimate fate of the universe, dictates the ultimate end of time itself. If dark energy continues to accelerate the universe's expansion, it could lead to the terrifying Big Rip scenario. This is a theoretical event where the expansion becomes so violently rapid that it eventually rips apart everything from distant galaxy clusters down to individual atoms, and eventually tearing apart spacetime itself. This would result in a state of maximum entropy, where organized energy can no longer exist, and time, as we currently understand it, would cease to have any meaningful existence. When you contemplate these 12 rules, the bending of spacetime, the absolute invisible limit of the Planck time, and the relentless, irreversible march of entropy, realize that time is not a simple river. It is a vast cosmic sea, a physical dimension that we are simply destined to be carried along its current. Now for the question, knowing what you know now about time dilation, if you could slow down or speed up your own personal clock, which would you choose? To experience more life, or simply to get through it faster? Let us know in the comments. Hit that like button and subscribe so we can continue to break down the largest, most fascinating mysteries of the universe.